Okay, these notes are Boyle's law notes, just like the lab we did today. Okay, Robert Boyle was an Irish chemist, and he described the relationship between pressure and volume in gases. Now, he found that if you doubled the pressure, the volume decreased by 1/2. And that's basically what you guys should have seen when you were using the books. We were adding more pressure. So the more you increase the pressure, the more that the volume should have decreased, the volume of air, because you're squishing it together. You're squishing all those molecules together. Now, Boyle's law states that the volume of a fixed amount of gas held at a constant temperature varies inversely with pressure. That means when one goes up, the other goes down. Okay, and this is really the mathematical formula for that. I know it looks like it varies directly, but it really varies inversely. So if you were to change just one of these, the other one would change the opposite way with the exact amount. So if you were to double the pressure, the volume should be in half, basically. Should be decreased by 1/2. Okay, so P1V1 equals P2V2. Now this is what's on the sheet that you have. What I'm going to show you next will be something you might want to write on the back. You don't have to. If you can solve for the variables without doing it, don't worry about wasting the space or wasting the time. But if you have trouble solving for variables, then you're probably going to want to write the next equations on there. Okay, well, P1 stands for the initial pressure, V1 is the initial volume, P2 is the final pressure, and V2 is the final volume. Okay, so what we want to do now is we're going to take one equation, P1V1 equals P2V2. And we're going to solve for one variable. I want to solve for the P1 variable. So I'm going to write P1 in blue. Okay. Now, to get rid of the V1, this is a multiplication. I got to divide both sides by V1. So we get P1 equals, because they cancel out, P2 V2 over V1. So if you're noticing what's happening, you're just moving the variable to the other side underneath the other two things. So we just moved basically the V2 underneath the P2 V2. So for V1, it's a matter of moving the P1 underneath it. So P1 goes from the left side to underneath the bottom, to underneath the right side. I can't talk today. So P2 equals P1 V1 over V2, and V2 equals P1 V1 over P2. Okay, so basically these are the four equations you're going to be working with the whole time. Okay, we're not going to really worry about the P1 V1 equals P2 V2, only because we have to, move the variables around. Okay, here's our first example. Now, one of the things that I'm going to require during the gas laws, and you guys are not going to like it, and some of you are lazy and you don't want to write it all out, but you're going to have to define what I call defining each variable. It's what I did in ICP. If any of you had me for ICP, you'd be defining each variable. So what I mean is you're going to put P1 equals, V1 equals, P2 equals, V2 equals. You're going to tell me from the word problem what each variable equals, and that way you'll know which variable you're looking for. So we're going to go ahead and put P1 equals, V1 equals, P2 equals, and V2 equals. And we're going to find out which one goes where. Okay, so let's read it. A diver blows a 0.7 liter air bubble. Well, we've got a volume here. Oops. Okay, my thing is messing up. So that's V1. 10 meters underwater. As it rises to the surface, the pressure changes from, now it's giving you two pressures. Changes from that one. So there's our P1. So I'm going to go ahead and write it there, to 1.03 ATM. And I'm going to go ahead and put our V1, 0.75 liter. And then it says, what will the new volume be? Obviously, we're looking for V2. So I'm going to put a question mark there. Now, I know I'm looking for V2, so I know which of those four equations to use. I'm going to use the V2 equals P1 V1 over P2. So V2 equals, now I'm going to put these in. Now since I have my variables defined with units, so I have 2.25 ATM, 0.75 liters, P2 is 1.03 ATM. I don't need to put my units in my equation. You've already told me by putting them down here, you've already told me that you know which unit goes with which number, okay? So you can just write the V2 part, which is 2.25. There's your P1. Your V1 is 0.75. And your P2 is 1.03. Okay? And it becomes 1.6 liters. So your answer is 1.6 liters. Now, why do I only have 2 sig figs when a couple of my numbers have 3 sig figs? Remember, it's the one with the smallest. Now, double check our math just to make sure in our brains, okay? So if you look at the pressure, it decreased by almost a half, okay? So actually a little more than a half, but it decreased, okay? So by just a little more than a half. So that means our volume should have increased by a little more than a half, and basically it did. So you know you're on the right track, you know you did it right. Okay, so the pressure of a sample of helium, and before we do anything, let's make sure that we write our P1, V1, P2, V2. Okay, so the pressure of a sample of helium in a 1 liter container, that's a volume, so there's our first volume, is 0.988 ATM. And that is a pressure, so that's our first pressure. What is the new pressure? Oops, put it in red. New pressure if the sample is placed in a 2 liter container. Okay, so just remember, anytime you see milliliters, liters, cubic centimeters, those are all volume units. If you see ATM, millimeters of mercury, any of those pressure units, you're dealing with the pressure. That's kind of how you tell the difference. Okay, so our equation is P2 equals P1 V1 over V2. So P2 equals, and we're going to just put the numbers in at this point in time. And we get 0.494 ATM. And double check it. Your volume doubled. Okay, so your volume increased by doubling. So your pressure should have halved, and it did. So, you did it right. Okay, so first thing I'm going to do is write P1 V1 equals P2 V2 equals. Okay, so a 355 milliliter sample of CO2. So that's a volume. So we're going to put 355 milliliters is under 98.3 kPa. Now, change colors here. If the pressure is increased to 900 millimeters of mercury, what's the new volume? Oops, we got a problem here. One of the things in all these gas law problems, especially when you're doing Boyle's law or Charles' law or any of those laws, the pressure units and the volume units have to be the same. They can't be different. You can't have kPa and millimeters of mercury and put it into the problem. You're not going to get the correct answer. So, since I started out with kPa, I'm going to go ahead and convert my millimeters of mercury into kPa. So we're going to take 900 millimeters of mercury, do our little picket fence, so 760 millimeters of mercury, and 101.3 kPa. When we do that, we get 120 kPa. Okay, so I'm going to go ahead and scratch that out and put 120 kPa. Okay? Now I can do my problem, and it's the V2 one again. So I'm not going to write the actual equation down again because I had it written 2 slides ago. So we know it's the P1 V1 divided by P2. So it's going to be 98.3 times 355 all over 120. And when you do that, you get 291 milliliters. Okay? Hopefully you guys understand this. We'll do a warm-up and do some more practice problems on Monday, and then I'll give you your assignment. So everybody have a good, long 3-day weekend. So I guess I will see you Monday. Bye.